Ngalakin kadijan nyunga boja.
Good morning, everyone. So we are going to start our practical class of the ELEC 440 now. And for this session, we are running that on the Microsoft Teams, and this session is being recorded. So everyone, if you do not want to be recorded, please turn off your camera. And in our practical class today, we have in total 7 questions given in the tutor 1. And some questions are pretty simple, like the question number 1. And some questions may a bit challenging. So before attending this practical class, I hope everyone has already watched the lecture 1 video and went through the section 1.1 to section 1.4 of the unit reader. And I hoped you may attempt these tutorial questions before coming to these sessions. And when I go through these questions one by one, you may just find, okay, that is why I don't understand this one. Or maybe, okay, this point, I can just simplify my works. So something like that. Of course, if you didn't manage time to finish the questions or attempt the questions beforehand, it's okay. So I'm going to try my best to go through as many as possible in this session. Sorry. Sorry. That means, okay, after this session, you still have to just go through the questions by yourself and just think about why I can't understand this question beforehand, or why losing write the solution like that. I maybe disagree with that. So if you have any questions after this session, please feel free to send me an email to ask me the questions. Just tell me, okay, this is 4404, tutor 1, question 3, I can't understand blah, blah, stuff. And then I will just get back to you as soon as possible. Okay, this thing here. Before we start the discussion here, just one more thing I want to remind you. It may be too early to mention that, but it's important, which is the class test. The first class test will be in week 4. The content of the covered in the class test 1 will be the chapter 1. So in other words, the lecture 1, the tutor 1 we discussed today, they are all covered in the class test 1. And I suppose the questions given in the class test 1 will be closely related to the tutor questions. Of course, will definitely not be the same, cannot be identical, but kind of similar. So some skills, some techniques, some methodologies you learned from the tutors will be important for you to finish the questions given in the test. So I highly recommend everyone to try all the tutor questions before or after the practical classes to make sure you really understand all the steps. Okay, I do believe this will be the same for the class test 2, class test 3. Maybe even for the exam. Okay, so in other words, tutorial will be important in this unit. Make sure you really understand each question and all the steps. The bottom line of these questions should be you are able to finish the question or similar questions by yourself without any help from me or from other classmates. Okay, this is another story. Before the class test 4, before the class test 1 in week 4, I'm going to give you more details in the practical class in week number 3 for you to prepare for the upcoming test. Okay, now let's stop talking about that. Let's go back to our tutorial. Okay, tutorial 1. Let's start from the easiest question. So question number 1. Please find, okay, lower f, fx. This is the PDF function. So maybe I should zoom in a little bit for everyone. Okay. So first of all, let's just interpret the whole question. This lower fx has a special meaning. In our lecture video, we have mentioned for the probability distribution function, we use a very special notation. So always lower f. So this fx means we want to determine the probability distribution function of the random variable. Keep going. If the capital Fx, the capital F is also a special notation. So this capital F means cumulative distribution function. Okay, we have introduced this one in our lecture. So if we have known the cumulative distribution function of the random variable x is something like that, how to find the PDF? Okay, this is really simple one. Okay, so for solving this question, there are two things you need to know. First thing, actually that has already been given in the question. So regarding this particular question, ux is the unit step function. So what is the unit step function? So I zoom out. I need to find some space for me to write my notes. Okay. So unit step function. So I believe you have studied this one a long time ago, maybe last year. Just happy to recall that. Ux is equal to, so only two possible values, 0 or 1. So when will the function, unit step function to be 1? So when the x is greater or equal to 0. And when the x is smaller than 0, so the function, the unit step function will be equal to 0. So that's the same. And its function curve looks like, oh, oops. The green color two segments. This is our x, this is our ux stuff. So this key point is 0. Look at that. This is the curve for the unit step function. But for this question, it's a little bit special because from this question condition, you can see we are using ux minus c. This is still the unit step function, but shifted to the right by c divisions. So that means if this is x, if this c, the ux minus c will be a function. So to be 0 before reaching c, and then change it to c, change it to 1 after the c point. This is our unit step function. Shift c units to the right. Okay, this is easy stuff. This is the first thing we need to understand. But let's finish a small part of this, okay? Regarding the given condition, so we have got the CDF function, so cumulative distribution function defined as this. And that unit step function is used inside. So how to understand this? Okay, so let's draw it, okay? So now what I'm going to draw is the CDF function, f x equals 1 minus e power to negative alpha x, then multiple u x minus c. So actually this CDF function is the term A multiple the term B, in which term B is the so-called u function, okay, step function, okay? So regarding the A function, the A term here, its shape is very simple. I think this will go course x is 0. When the x is 0, this exponential term becomes 1. 1 minus 1 is 0. So that means for the term A, it will go across this 0, 0 origin. So its function curve looks like this. And when the x is approaching to infinity, so this term A function curve will approaching to 1. This is what happens regarding term A. But regarding this CDF function is the product of term A with the term B. So in other words, we need to multiply this term A with that unit step function we defined. So this is x, u, x minus c. For example, if c is here, so what we will have is another curve, looks like this. Sorry. And what we are going to do for the CDF function is to do the multiplication between the A term and the B term to produce the product of these two curves. This production is actually the point-to-point multiplication. This is good because regarding this unit step function, before reaching the point C, the value of this function is always equal to 0. 0 multiple whatever you have here, the result will be 0 as well. So the product between these two functions, so term A and term B, between the point C, I mean before reaching the point C, will be, now this is CDF function, okay? Before reaching the point C, the CDF function will be 0. So how about after the point C? So after the point C, the unit step function will be having the value 1. 1 multiple whatever is the whatever. So in other words, after the point C here, we just need to make a copy of the term A curve in the CDF function. So that means something like that. This is for smaller than C segment. This is for greater than C segment. And this red color curve is our CDF function for this question. From our drawing, you can see here is continuous. The shape of the CDF function is not a stepwise style. In other words, this random variable must be a continuous random variable, cannot be the discrete type random variable. Because for discrete type random variable, it looks like a step-by-step thing, something like that. But this is not the case. So of course, this is not the discrete type random variable. It must be continuous one, okay? Okay, now let's go back and I'm just going to wipe off this stuff, okay? Sorry. And now let's solve this question. Because we have already known this random variable x is a continuous type random variable. So what we are going to do is to use the relationship or definition of the PDF to calculate it. In the lecture, we mentioned how we define the probability distribution function lower f. So the lower f x is the differentiation of the cumulative distribution function to the x parameter. So we just put this in here. Of course, normally we put the name of the random variable next to the PDF and the CDF notation. But for this question, I think that is just ignoring it. But normally we should do that, okay? Okay, let's just keep going. For this question, the calculation should be very simple. dx doesn't change because we have already known the mathematical expression for the capital F, the CDF function. We just put it in, which is 1 minus e power to negative alpha x, the first term, multiple u x minus c. By the way, I forgot to mention, so such function is the second knowledge point you need to know regarding this question. Okay, the first one is about the unit step function, and this is about the definition of the PDF function. Okay. Solving that will be just a mathematical induction. I believe most of you or everyone can do that. But anyway, let's just go through them together. Okay. So this will be equal to we mentioned this is our term A. This is our term B. A is function of x, B is a function of x. So if you do the derivative of ax by the bx, the result will be equal to ax depreciation by bx plus ax by the bx depreciation, mathematical rules, right? So we just use this one to solve this question. So for this question, what we are going to do is just to calculate the depreciation for each of the two terms based on that rules. We got 1 minus e power to negative alpha x derivative by u x minus z plus, so second term, keep the term a unchanged and multiple u x minus c derivative. Okay, and next step, that is another important property of the unit step function, which you have learned from the another unit, signals and system. If you have got the unit step function, so what will be the derivative of it? That will give you the unit impulse function. So what is a unit impulse function? So delta x equals c, much easier than the step function. That is equal to 1 or 0, only two values. But only when the x equal to c, you have that number 1. Otherwise, for all other values, it will be 0. Its curve looks like this is the x, this is our delta x minus c, and at the point x equal to c, you got a unit impulse. The height is 1. So this is so-called the unit impulse function, okay? Of course, it's shifted to c position, okay? So in other words, in our calculation, the second half should be pretty simple. This is equal to 1 minus, this part doesn't change, just keep that here. But for the first part, we need to do some calculation, but should be pretty simple, okay? U function doesn't change. But for the first, the term a differentiation, 1 becomes 0, that's okay. Negative sign doesn't change, and e power to negative alpha x differentiation is itself. And then multiple negative alpha x differentiation is give you, just give you alpha multiple e power to negative alpha x multiple u x minus c plus. Okay, I think that the term a is pretty simple. The first term we have done, all right? That's okay. Regarding the second term, you need to do one more thing. You are using this exponential function, multiple this delta function. This could be very, very simple. We have known this is the unit impulse function shifted to the c position. We are going to use this delta function to multiple the 1 minus e power to negative alpha x, which is a function looks like this one. This is 1 minus e power to negative alpha x. So we are going to calculate the product between these two functions. If you are using this one to multiple this one, all these 0 value points, these 0 value points will cancel this segment and this segment, because for the delta function, the values of them are all zeros. Sorry, they're all zeros. So after you do the multiplication, the values of the green curve are all cancelled, except one single point, which is at the position C. This value is kept by this unit impulse. So in other words, when you use a function to multiple unit impulse function, so this unit impulse function will return you one single value of the function at that C point. So after you finish this calculation, this will give you the result. At position C, you got one impulse, but this is not the unit impulse anymore. the height of this impulse will be the height of this curve at position C. In other words, the height of this point will be 1 minus e power to negative alpha, where the x is equal to C. Only this one single impulse. Okay? But anyway, this is another small story. We just keep this in here, just to give you some information. I want to keep my work to be the same as the solution which you can download from the LMS. Okay, just keep it here. Just give you some idea. Okay, this is the question number 1. Sorry for the massive writing, but I hope this can make some sense for you to review what we have learned from lecture. And before moving on to next question, I want everyone to understand this PDF function is very special. In addition to this in addition to this continuous part, you have one very special impulse at position x equal to c. In other words, this PDF function curve is not smooth completely. It has one impulse in the smooth curve. This impulse is because the corresponding cumulative distribution function has discontinuity at position C. I remember in the lecture I mentioned, if the cumulative distribution function has discontinuity, please be very careful, because you may have some impulses and we are not able to evaluate the derivative at that discontinuity point. Okay, so this is the issue. Okay, this is question number 1, and I will temporarily pause the recording. Press the function.